Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is about additional content for continuous random variable is where we want to change the cumulative distribution function back into its probability density function. Okay, it means that we initially have cumulative distribution function that is written with this capital F symbol, and we want to change it back into the probability density function back to this symbol. Okay, so usually for cumulative distribution function we have it written in the form like this. So 0 x minus 1 square over 25 and 1. So for 0 is where the x is less than 1. This is for 1 less than or equal to x less than 6. This one is x is bigger than or equal to 6. Okay, so the question is here, how can we change the probability density function, change it back into probability density function? Alright, so the method is to apply differentiation for each region. Okay, for region x is less than 1, so we have to differentiate dfx over dx. So that means we have to differentiate d over dx of 0, so it means we get a 0. So then we proceed for the other region. For region where 1 is less than or equal to x less than 6, so the dfx over dx equal to d over dx of x minus 1 square over 25. So we need to differentiate this equation. So what we get from here is it will be equal to 2x minus 1 over 25. Okay, so this is the differentiation. Okay, then the next region is for x is bigger than or equal to 6. So the dfx over dx equal to d over dx of 1, so we also get 0. Okay, so because if we want to change from probability density function until cumulative distribution function, we apply integration. So in order to change it back from cumulative to probability density function, so then we apply differentiation. Okay, so that is the concept for this method. Okay, so now we have the probability density function for each region, so then we need to rewrite it back into its formal form. So then we write fx is equal to, so since this one is 0 and 0, then we can just make it together. We write down this equation first. So 2x minus 1 over 25. For region 1 is less than x less than 6. So for both zeros, we just write down 0 for the otherwise. Okay, let's do another example of changing cumulative distribution function into probability density function. So the cumulative function is fx equal to 0 x over 20 minus 1 over 10 x over 10 minus 3 over 10, and then we have 1. So the region is where x is less than 2, 2 is less than or equal to x less than 4, 4 less than or equal to x less than 13, x is bigger than or equal to 13. Okay, so now we apply differentiation for each region. So x is less than 1, the fx is equal to d over dx. So that's mean we have to df0 over dx, so it just equal to 0. Okay, the next region is 2 less than or equal to x less than 4. The fx becomes d over dx of x over 20 minus 1 over 10, so that is equal to 1 over 20. Okay, for 4 less than or equal to x less than 13, the fx equal to d over dx of x over 10 minus 3 over 10 equal to 1 over 10. And then for region x is bigger than or equal to 13, so the fx is equal to d over dx of 1, so then we have it equal to 0. So now let's write it down into its. Okay, so fx equal to 1 over 20, 2 less than or equal to x less than 4, 1 over 10, 2 less than or equal to x less than 4. Oh, sorry, this one is actually 4 less than or equal to x less than 13, and then we put 0 for the otherwise.